Welcome to lesson 11.1, your first lesson in your take-home spring break unit. Today we're going to talk about two different types of graphs when we talk about statistics. So this unit is all about data and how we represent data and look at data. So the first lesson, your aim is that you can interpret dot plots and histograms and create your own, given a data set. So we're going to talk about quantitative data. So quantitative data on a single variable is often collected in order to understand how a characteristic of a group differs amongst group members or between groups. This is like saying, when we ask a question like, how old is a typical fast food worker? It's helpful to take a survey and then see graphically how the ages differ. So quantitative data is where you collect information like, oh, how many people like Donald Trump, or how many people like this type of music, and you count up all the people and then you can display it graphically. So exercise 1, here's the situation. Charlie's Food Factory currently employs 28 workers, whose ages are shown below on a dot plot. Answer the following questions based on the plot. So here is this display of data. The graph says here's the ages of workers. So some people are 15, 20, some people are 16, 17, 18, 19. Sometimes it helps to label these little numbers in between. And it goes all the way up to the age of 41, 42. Okay? So A says how many of the workers are 18 years old? So I'm going to go to my dot plot. This is called a dot plot because there are dots labeling it. I'm going to go to 18. So here is 18 right here. I'm going to count 1, 2, 3, and 4. So there are 4 workers who are 18. Okay? The next question is saying, what is the range of the ages of the workers? So range, and we've heard this word before, but range in terms of a data set, range is the lowest to the highest. Okay, and usually we're going to think of this as subtraction. So in other words, you can say the oldest minus the youngest. Okay, so this is how you find range. You want your biggest number minus your smallest number. Okay, that's the definition of range. So my youngest person that works here is, there's no one that's 15. So see 15? There's no one here, but then I can see my first youngest person is 16. I've got 2 people that are 16 years old. So my youngest, and I'll make that blue so we can see it, my youngest worker is 16. What is my oldest worker? Well, if I go on the dot plot all the way to here, this worker right here is 42. So I go to my oldest right here at 42. That is my oldest worker. Okay? So now I'm going to do oldest minus youngest to get my range. So 42 minus 16 is 26 years. So the range of ages, it ranges 26 years. Okay, that is my range, 26 years. All right. So 2 things you've learned now. You've learned how to take a look at a dot plot and label where the dots are, and you know how to find range. Okay. Continuing with this data set with C, would you consider this distribution symmetric? Okay, now symmetric is not something we've talked about a lot, but symmetric is when 2 things are identical on either side. Like, for example, if I draw this shape right here and put a line down the middle, it's symmetric because it's the same on both sides. If I were to bend it like a piece of paper, they would match up. That's symmetry, right? Another shape that is symmetric would be like if I drew this. That's symmetric. If I bend it, it'll be the same. So now I'm looking at this picture. Is this symmetric? Does this have symmetry? No. If I bend this entire box, this entire dot plot, it's not going to match up. There's way more here than there is over here. Okay, that's not symmetric. So no, it is not symmetric. There are more young people than older people, right? This is not symmetric. If it were the same on both sides, there were equal amounts of young and old, then it would be symmetric. That's not the case here, okay? And finally, letter D. Okay, the mean average age for a worker is 22 years old. So, the average age, if you basically look at anyone that works this place and pick someone out, you're likely to get a 22-year-old. But why is this average not representative of a typical worker? Okay, and the answer to this question is very interesting. So the idea here is if I go into this restaurant and I pick out a random worker, what would the likelihood of their age be? What would their age be? I likely pick out this one guy that's 42 years old? Probably not. I'm more likely to pick out someone that's here. Because count how many people there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 people, and if I include the 20s, that's 12, 13, 14, 15, 16 people that are all 20 years old or younger. So the typical worker is actually about 20 years or younger. So, because the majority of workers are 21 to 20 years old or younger. That's your typical worker. 22 is finding the average, where you add up all the ages and divide up how many there are. That's not representing the majority of the workers, right? 22 is actually right here. There's 22. One guy is 22 years old. That's not your typical worker. Most of the workers are between 16 and 21. Okay? So this is your introductory to dot plots. So let's take a look at making our own dot plots. So exercise 2 is about making our own. So a farm is studying the weight of baby chickens after a week of growth. So he's got these chickens, he weighs them after a week and gets all this data about how much they weigh. They find the weight in ounces of 20 different chicks, and the weights are shown below. Construct a dot plot on the axis given. So I'm going to go through each number, and I'm going to start making a dot plot. So I see the number 2. I'm going to make a mark on 2. I'm going to make a dot, and I'm going to cross that 2 off because I've made a dot there. I'm going to go to 1, cross it off, make a dot here. Okay, I see 3, I'm going to make a dot on 3, cross it off. The next one's 4, make a dot, cross it off. And I'm going to keep going this way where I'm making dots and I'm crossing them off at the end when I'm done so I can keep track. There, the next one's a 3, so I make a 3. I see another 1, 5, cross it off, 3, another 4, another 4, a 5, cross it off, a 6, cross it off, a 3. You can see how you could easily lose track of your dots if you're not crossing them off when you're done. Okay, a 5, a 4, a 6, and finally that last 3. Now, when I count my dots, I'm going to count these dots up here and make sure I have 20 because I want this 20 number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 dots, 20 chicks. I've used all of my numbers correctly. Okay? That is the basics of a dot plot. Okay? There's really nothing else to do. They've already given you this title here, which is really important. You should always have a title. Okay, if they don't give you one. But that's the basic of a dot plot. Okay? So related to a dot plot, the other way we're going to learn how to graph this kind of data is using something called a histogram. A histogram is very similar to a dot plot, but instead of making dots, you're making boxes that go all the way up. Okay? So the following histogram shows the ages of workers at the food factory from exercise 1, but a different format. So this graph right here uses the exact same data as this one right here. So we're still looking at Charlie's food factory with the ages of workers, but now we're just representing it in a different type of graph, a histogram. So letter A says how many workers have ages between 19 and 21. So I'm going to go look here. Here's 19 to 21 right here. And now I'm going to see how many. So how many does it go up to? It goes up to 11. So there are 11 workers between 19 and 21 years old. Now this is a nice thing about a histogram because in a dot plot, like if I go back to the dot plot between 19 and 21, I'm going to erase some of this here just so we can see a little better. But if I go to the dot plot and look at the ages 19 to 21, so here's 19 to 21. Oh, I wrote 91. I would have to count up all of these dots right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I still get 11 workers, but it's a lot harder to see in a dot plot. The histogram made it a lot easier because it broke up a range of ages and then put it all in one bar. And I can just see 11 right away without counting. Okay? So that answers my letter C, because if I look at this question, what does the histogram have advantages over with the dot plot? It is much easier to see totals. Okay, I don't have to manually add up, right? I don't have to count dots. That makes a histogram much easier. But what's a disadvantage of the dot plot? I can see that there are 11 people between ages of 19 and 21, but I don't know exactly how many are 19, exactly how many are 20, or exactly how many are 21. So I can't see individual ages. I can only see the ranges of that data. So that's one disadvantage. So sometimes we have to choose what graph we want to use for what situation based on what we want to think about, right? If we wanted to see individual ages, a dot plot would be good. But if I wanted to see how many people were in this group, 19 to 21 or 16 to 18, a histogram would be a much better choice. Okay? So let's practice making a histogram now that we can read one. So a histogram has two parts to it. You first got to count up how many data points are in the range, and then you have to draw the histogram. So we've got a new set of data here. Exercise 4 is the 2006 to 2007 Arlington High School varsity boys basketball team had an excellent season, compiling a record of 15-5, 15 wins and 5 losses. The total points scored by the team for each of the 20 games are listed below in order in which the games were played. So for example, on game 1, they scored 76 points. Game 2, they scored 55. Game 3, 76, and so forth. Okay? So it wants us to complete a frequency table first. So a frequency table is we're going to count how many times this team scored between 40 and 49. That's what tally means. It means count how many times. So I'm going to go through my list and look for what's between 40 and 49. The first one I see here is 46. So there's one already, and I'm going to cross it off when I see it. Then I'm going to keep going, and then I see another one, 46. There's another one in that range. 45 is another one, so I'm making tallies. I don't see any more, so there are only 3 games where they scored between 40 and 49 points, and so I'm going to convert that tally into a number. They scored between 40 and 49 points 3 times. Now I'm going to do the next set, 50 to 59. I'll use a different color here. So I'm going to go through here, and here I see 55, so that's one tally. I see 53, there's another tally. 56, a third tally. 53 falls into that range, a fourth tally. 57, a fifth tally. 58, a sixth tally. And 52 and 58, so 2 more tallies. So that's a total of 8 times they scored between 50 and 59. Next, I'm going to do 60 to 69. Start at the beginning again. There's a 64, so there's 1 tally. 65, there's a second. 67, there's a third. 64 and 67, there's 2 more. And finally 62, there's a 6th. So they score between 60 and 69 6 times. And between 70 and 79, that's 76 falls in that tally. Another 76, there's a second one. And that looks like all. There's just 2 of those. Okay, let's pick yellow for 889. And if I notice here, the only numbers I have left are 91. So I have no tallies for that. So that frequency is just 0. Okay. And finally, my last one, I have 1 at 99. Okay, now if I count up, if I add all these together, 3 plus 8 plus 6 plus 2 plus 1, I get a total of 20 numbers, right? 8 plus 3 is 11, 11 plus 6 is 17, 17 plus 2 is 19, 19 plus 1 is 20. So your total tally should be 20, which is the total games they played. They played 20 games, so you should have 20 total tallies. It's a good way to check and make sure you've counted properly. Okay? Now we're going to make the histogram. So I know that my numbers go from 1 to 20, so I can label this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, because I want my frequency on the left. So this on the left is like my frequency. Okay, and it's basically my number of games that they scored that many points. So how many games did they score? 40 to 49 points? 3. On the bottom of my histogram, I need to label that as well. And the bottom of my histogram is my number of points. And I have to write it as a range, and so I'm going to give myself a little bit of space here, and I'm going to say, I'm just checking to make sure I have space. So I'm going to say from here to here, this will be the range of 40 to 49. Okay? And on the next one, the next range is right here, and that's going to be 50 to 59. Right there. The next range is blue, and that is from 60 to 69. Then I have green, which is 70 to 79. Yellow is 80 to 89, which I know is really hard to see, and I'm sorry, I ran out of colors. And then finally the last tally is that 90 to 99. Okay? Now I'm going to draw my histogram. Now remember, I'm going to go back to the previous slide. A histogram has these boxes. See, I've already written the ranges, and now I've got to draw my boxes to my total amount of tallies I had. So how many tallies did I have for my purple, for my 40 to 49? I had 3. So I'm going to draw a box up to 3, and, shade it in. Okay, so there's my tallies for 3. Okay, then I'm going to do red. How many tallies did I have for red? I had 8, so I'm going to draw a box all the way up to the number 8 and shade it in. Then I'm going to do blue. I had 6 games where they scored between 60 and 69, so I'm going to go up to 6 and make a bar. Green, how many games did they have? 70 to 79. They only had 2, so I'm going to go up to 2. Yellow, they had no games, so I'm not going to draw any box for yellow because there were no games they scored that. But for games between 90 and 99, they had 1 game. So this is my finished histogram. The really important thing to remember with a histogram, it's different than a bar graph, is that the bars must touch. Bars must touch. See how the bars are right next to each other and they touch? That has to happen in a histogram. So that's the one key thing. If these bars don't touch each other, it's a bar graph, not a histogram. Okay, so please keep this rule in mind. The bars have to touch each other, be right next to each other. Okay, that's it for lesson 11.1 in your take-home unit. Please take a close look at the fluency, and if you want to go through your take-home exam and see if there are problems about dot plots and histograms, I would do that. You don't have to do the take-home exam at the end of all of these. You can do it as you go, which might be a good strategy. Okay, please feel free to reach out to me if you need help. I am at home over spring break, so good luck.